Okay. Let's get started. Another week, another 3 more chapters. I do want to start, though, by making a reminder that we are about 5 weeks away from the end of the course, about 5 or 6 weeks away. So I know that this is the time when students start ramping up, turning in assignments. So I'm going to do my best to stay on top of the assignments and get them all graded as they come in. I believe in this course we actually have some buffer time. So if you have fallen behind, you will be able to catch up without any problem. And again, all assignments have one set due date. So you are able to turn in stuff that you have fallen behind on without any consequence. But when that due until date is met, then I won't accept any more assignments. So till then, you are still able to catch up, and I hope you're not falling behind. But if you are, you do have some grace period to catch up. And I know this is when students start turning in stuff, as I know I did it too when I was in college. Life happened. So I am not going to punish you because life happened. I'm just going to remind you that I am aware that this is the time when you'll start turning in assignments. So I'll be more vigilant to get your stuff graded ahead of meeting that deadline in December. So with that, and if there are any questions, always ask away. Cool. Then we'll continue with Hyper-V. And then we have 2 chapters based on high availability. So chapter number 7, Hyper-V Part 2. As you have seen with working with the desktop, you have 3 main types of virtual hard disks: the fixed sized, which won't increase; the dynamically expanding, which is the more preferred. It says it's slower, but it's really really fine for most applications, unless it is a disk intensive application, such as database. If you have a database VM, you more than likely want to use a fixed sized. And then there's differencing. Sorry. New disks are easily created with the wizard. You'll either do the VHD for any old type of VM, like you're running XP or older, a VHDX for the current, and you can do VHD set if you're sharing the disk in a cluster. And there's the wizard. Again, the VHD set is something new, so anything other than Windows 10 won't necessarily work with it. You'll choose your disk type. You'll say how big, if it's a file, or if you're actually connecting a physical disk. They are typically created in the default location unless you choose another path. And then once it's created, then you can use that same wizard to edit a virtual hard disk to either compact it, convert it, expand, merge, or reconnect. A pass-through disk is essentially a physical disk that's connected to a VM. It lacks the flexibility because it's a physical disk on the other side. And you're limited to a 2 terabyte size. But it is possible to connect a physical disk that's attached to the host to a virtual machine direct. And that's where you define it. Within, you would add the hard drive and say, hey, here's my physical disk that I want to connect. There is a storage QoS to set performance values. It will affect other VMs if you have multiple VMs running on the same host, and can be set on either the IDE or SCSI. So good to set up for critical infrastructure, but know that other VMs on the same drive will feel that effect, especially when there's a lot of read and write happening. So within the SCSI controller, you can define the quality of service and see the minimum number of operations that can happen and the maximums. The two main policies are the aggregated and the dedicated. Setting the dedicated will set your minimum and maximum. Your aggregated will set that to a set of virtual disks, whereas dedicated will be for each specific disk. Your virtual networks will function in the same way, especially if your drives are your hard disks, your virtual disks are on the network. They'll also have that same functionality. In Hyper-V, you have what's called the external virtual switch. That is what basically will connect the virtual world with the physical world. And you can only have one external switch per physical network adapter. You should have more than one NIC installed on a host, just because there's a lot of traffic that can come out of VMs, especially if you have a lot of VMs on the network, you're gonna have a lot of traffic. So it's a good idea to have multiple NICs to either load balance or have a failover, or just have more bandwidth. All right, so once you set a NIC as the external virtual switch, Windows will bind it and unbind any other protocol. So it becomes essentially dedicated to being the outbound and inbound for that switch. So you see when it's not part, then they can do anything and everything. But once it becomes bound to it, it will be the gateway out, essentially. Your internal virtual switch allows your VMs to communicate to one another. Because it's internal, it's all happening on the CPU. So all the traffic is completely virtual. It works the same way, getting addresses from a DHCP server, either internally or externally, or it could be completely isolated. You can see and talk to other hosts on the same subnet, but it's all virtual. It's all on the CPU. It's not at all going out to the world. So great if critical infrastructure is necessary, and there's a number of VMs that make up your critical infrastructure. They can communicate with each other at high speed without the need of fiber or other really expensive networks. Now, the traffic that occurs between these two will only run through the CPU and never get out. You can make private virtual switches. Similar to internal switches, except the VMs that are connected to this private virtual switch cannot communicate with the outside world. It's basically an internal switch without a way out. So there's the NIC pointing out to the world, but a private switch will only connect VMs together and not out. So great for testing, great for, like I said, an internal communication that does not need to talk outside. You still get all the benefits of the high speed communication, just no connection out. You can connect an external and a private switch. You can also create internal virtual switches with routing if you have an isolated network and then you want to join it. And this is all true because the virtual network is exactly that. It's all software based. So changing configurations is way easier than doing a physical switch and adding more devices and more cabling and whatnot. All software based makes it easy to make these changes. Just like with other items, creating a switch is done through a wizard. So you create a new switch, it'll ask what kind of switch are we looking to create. You give it a name, any notes, information, and VLAN if necessary. You have to have a MAC address. You can have Hyper-V dynamically create these or use a pool yourself. So there's the global network setting. And again, you can extend it if you like. If you have more VMs than MAC addresses. Your virtual NICs are always created when a VM is launched or you add one or you import a VM in. Because it's all software based, it's easy to remove, disconnect, do anything. So here you can add a network adapter. Once it's created, you can set up to what switches it's connecting, any VLAN, any bandwidth management. Switches can help with other configuration tasks like hardware acceleration. There's advanced VNIC features. There's NIC teaming. This is synthetic versus the network adapter and fiber. So hardware acceleration, you have the VM queue, virtual machine queuing, the IPsec task offloading, and the single root IO virtualization or SRIOV. With VMQ, we can accelerate the performance by delivering packets from the external network directly to the VNIC. So any traffic that is destined to a certain VM will get priority. We have the IPsec task offloading. Any IPsec security associations will be offloaded. And SRIOV will enhance the performance by bypassing the virtual switch and communicate directly with the physical hardware. All different ways of handling the traffic that's coming in and out and dealing with it quicker. Did I go backwards? I think I did. Yep. Your advanced features that come with your virtual NICs, because it's all software based. You know, the MAC address, we can spoof if needed. We have DHCP and router guards. We can make protected networks. We can mirror any ports if we want to do packet analysis and device naming. All available within the advanced features. We can also do NIC teaming. Great when we have critical infrastructure that needs to communicate to the outside world. and we want to give it as much bandwidth as possible. You need at least a second NIC. They can handle load balancing. They can handle failover. You can set all that stuff out in Hyper-V. And some of this can be done with PowerShell in either the Server Manager or PowerShell. Here it is within Server Manager. You have three main teaming modes: the switch independent, the static teaming, or LACP. When it comes to load balancing, we can do address hashing, the Hyper-V port, or dynamic. Virtual machines will have the same procedure as physical computers. If we're choosing to establish disk teaming in the guest OS to provide redundancy, we can enable this. The switch embedded teaming, or SET, is a new feature to Hyper-V that allows up to 8 physical adapters to be configured as a team. So again, great for very fast and huge bandwidth for 8 NICs to work together as one. It supports the remote directory memory address for virtual network adapters. And of course, that has to be enabled on the host system, who has the up to 8 adapters, or the 8 NICs. The synthetic network adapter is available on Gen 1 VMs if integration service is installed. Gen 2s don't support legacy network adapter. With Gen 1s, if your OS doesn't support the synthetic network adapter, or you need Pixie Boot, then you'll need to use Gen 1. Otherwise, Gen 2 will be your way to go. Synthetic is just another way of saying, a better NIC than the legacy. And it is possible to connect a fiber channel storage directly from a VM, or clustering VMs, and connecting them into a SAN. And you can add that as well. You can connect that fiber adapter into a VM to give it that capability. It is possible to do nested virtualization if needed, which is basically running a VM within a VM, not a container, but another virtual machine within a virtual machine. Hyper-V isn't able to do any VM within a VM, but it can do some. And obviously, you can't use dynamic memory since 2 VMs are running. And you can't live migrate one that is running a Hyper-V. Hyper-V does run Linux systems, so don't feel that Hyper-V is a Windows only, especially with Azure. It is possible to run any and all OSs. Cool. Any questions? Okay. So we'll hit stop. copy these over here to convert later. Open up a second. And now high availability. All right, chapter 8. Network load balancing provides scalability and fault tolerance in a server cluster, a group of servers responding as a single IP address. This is how it is possible to handle more traffic by adding more servers who still respond to the one request. So we have our client machines connected to a network. Whenever they ask for any information out of this IP address, any one of these three will respond because they are all in a network load balancing cluster. They don't have any special hardware requirements. All the participating servers should not be providing services other than whatever the cluster is providing, because otherwise that's going to become confusing to the boxes. NLB should be installed on each server who's going to be part of this cluster. Each server should have 2 NICs, one for communicating with network clients and the other one for members. And of course, you can add this in Server Manager or PowerShell. So in this example, we have 2 switches. One switch that would be facing outward to our clients, and the other one where our cluster communicates with each other. Doesn't have to be 2 physical NICs. It could really be 1 NIC, and we have a VLAN where this dedicated communication is happening separate from these guys. Any number of array can be done to achieve this same goal. To create a cluster, it takes a couple of steps. I got to create our cluster, got to give it, select the host, set any priority and host IDs, set that cluster address, and then add all the other servers. There is the network load balancing manager within Tools and Server Manager where you can create the new cluster. Again, you must specify a host, and you would enter the server name. Once it's connected, it'll ask what network interface will be used in the cluster. So that's the one that will communicate with the outside world. Here it looks like it's Ethernet in this example. You can have up to 32 servers in a single cluster. And you can choose the priority value depending on, maybe you have different servers with different CPU and memory and different levels of resources. So you can choose to have maybe the first server be the one that's most beefiest and just go in descending order, or the other way around. However you choose, you can give them priority. You'll set the virtual IP address. That's the one that any of the hosts will respond to. You'll need a DNS record on your local network. If you have 2 NICs, then the cluster address will replace the one that will be facing out. Now you'll need an FQDN, and then you can choose which way the cluster will operate. Will it be unicast, which is the default, multicast, or IGMP, multicast? And there's the options. Your port rules will say which ports will be handled by the cluster. and how that traffic will be distributed among all the members. The higher the load weight, the more traffic that a member will handle. So here's the port rule. No priority was set, no load was set in this example. Once all that is done, now we can add more members into our NLB, which again, they have to have the feature already, and then you can add their interface and a priority. So here we are with our new cluster, and we're going to add another host by right-clicking. And again, the cluster is the configuration of the cluster is in 3 parts. And like you saw, you would right-click and then go to the properties, which you'll have things like the IP address and other parameters that you can set. In most cases, you will want to set the port rules to accept communication on the cluster address only, because that is the whole point of that cluster. And those port rules will apply to all hosts that are in the cluster. So you only have to set it in one place, and it'll take effect everywhere. Your filtering can be multiple host or single host. The host with the highest priority will handle all the traffic, or the traffic will be load balanced between everyone. You also have the affinity value of any cluster could respond, the request from the same client directed to the same cluster host, or a single cluster will respond from a specific IP network. So you have different ways of handling the traffic coming in and out. And you do have host-specific properties. If you right-click a host and hit Host Properties. It'll show the cluster's IP address, any parameters, and port rules. You can use the port rule tab to edit any of the port rules that aren't set to disabled. Once that's all done, then you'll need to perform maintenance, of course, because nothing is set and forget, which you'll do within the NLB manager. You can control a single host through this manager, so you don't have to go to the individual systems. So here you see from this panel, we can start, stop, drain, stop, suspend, or resume as we need. To upgrade a cluster will require taking the server offline, doing that upgrade, and then bringing it back online. So it's not something that can be done on the fly. It is something you would have to schedule out and prepare for and plan when you have the lowest amount of traffic, so that you can have more servers down, do the upgrade, and bring it up without affecting your clients or affecting connectivity. You have some items here to keep in mind, like verifying all the clusters support the new version that you're upgrading, using drain stop on each host before you begin the upgrade, and then set the initial host state to stop, and then making sure all services work after the upgrade before bringing it back into the cluster. So upgrading is not as straightforward. It's going to take a few steps. And it's going to require some manual work. And there is a table, and I'm sure you can simply Google to get the list of commands that you could use through PowerShell. Now, failover clusters are used for high availability. This is well suited for your mission critical applications, things that must stay on always. We can cluster applications like a web server. We can cluster a complete server. We can do active nodes, passive nodes, and standby nodes. Here are some terms that Microsoft uses in this realm. We have the quorum, the database containing the configuration and status of each node in the cluster. We have the heartbeat, providing the status of each node, and the witness disk, a shared storage to store cluster information. Obviously, with failover, you need at least 2 servers, and both of them should have identical configuration. Both of them should also have access to a common storage media, like a SAN. So if one server goes down, they're able to communicate through the SAN or be able to tell each other and be able to continue that mission critical service no matter what. So again, we have 2 or more servers together using shared storage to provide fault tolerance and high availability. Our client computer can see a failover cluster as a single entity, since it doesn't need to see how many servers are running. All the servers will have access to the application data. So in case one fails, another just takes over. Passive servers will know when an active server is no longer able to work through the quorum process, which basically just checks the cluster status. And if it sees one of the servers going down, then the passive server could become active without you having to set the switch on. It can do it automatic. There's different ways, different models that you can employ this, and they're listed here, like the node majority, the node and disk majority, node and file share, no majority, and cloud witness, where we're using the cloud and not just on-prem systems. Again, your requirements should have at least Server 2016. They should be identical or nearly identical to each other with the same architecture. You should have separate adapters to communicate to storage and separate for network. So you should have at least 2 NICs. Should be in the same domain. And any apps or services should be the same version number. Your storage should be, again, available to all members. It's required if you use the disk majority or the no majority. And you should have digitally signed drivers connecting your storage together. Installing it is through either a wizard or through PowerShell. You can perform the verify step before installing the feature to make sure everything is ready. Everything works, everything connects. Then you would run the validation wizard, which is the failover cluster manager added to the admin tools after you install the feature. You install, it'll prompt you for names and other settings to set up and to test. This is what the Failover Cluster Manager looks like. Once it's installed and verified that the system can be in a cluster, then you'll set up the cluster itself. And making sure that it has an IP address and DNS entry is in, that it is in Active Directory and all that kind of stuff. Once the cluster is created, you'll have a few more tasks to do. It's definitely not a one-step setup. Then you'll connect the cluster networks. Again, you should have at least 2 separate networks. But if you are able to do more, then awesome. And ideally, you want to have them communicate separate from everything else by having different subnets. Since a lot of, especially the cluster communication can be very chatty for heartbeats. So it is good to have an alternate network for that communication only. Since any delay in a heartbeat can cause an effect of starting up other systems, and it could cause some mayhem as long as it's not set up right. You can configure the quorum model if that's the way you choose. And again, it has a wizard. The cluster storage. Again, all the systems in the cluster should be able to access it. So that'll definitely need to be added. Has a number of benefits of using the cluster storage. Again, by having this in place, you definitely have some benefits of minimizing bandwidth and quality of service. Having the network and file printer sharing so that adapters can carry that cluster communication. And really having it separate from everything else. So this is one of those essential traffics that you want always to work. Then you can go into the failover cluster and set up your roles as needed. Setting up your client access point. Of course, the role has to, or the feature has to be installed in every server that will be part of this cluster. You can do cluster aware updating, which is an automatic software update to maintain availability, and it's a simple process to enable that. This will help with Windows Update. Like I said, this is part 1 of 2. So let me hit stop to this. Move these over here. And do the next part. And this is part 2 of high availability, advanced failover, and virtual machines. So you create your clusters. Of course, as with everything else, it's not just set and forget. You'll need to do some management, like validating the configuration. Maybe you'll need to add or remove nodes, or shutting down, restarting the whole cluster, removing or destroying it, copying any roles, or moving resources. To validate, it's simple through a wizard. To add remove, it's pretty much the same way where you'll go through the add node wizard, add a server name. And again, that server already has to have the feature installed. The quorum settings will get updated. And to remove, it's a little easier. You'll just right click and evict. Shutting down a cluster will stop all the roles and the services in that cluster. You can, if you need to shut down the cluster, you can do it within the FCM. Same with restart. And you can also start a cluster service on a specific node as needed. You know, if one isn't acting up right, you could call it restart. To remove, it's similar, right-clicking the node and selecting remove. And same with destroying. It is also possible to migrate the roles, but you can't migrate these roles: the cluster aware, the task scheduler, volume shadow copy, exchange, or SQL. For all the other roles in the cluster, you would open the FCM in the target, and then right click and then select copy cluster roles. The source can't be where you're running the wizard. You have to run this wizard from the target. When doing maintenance, you'll need to move the resources from one node to another, because again, this is all about high availability and ensuring that whatever services we're offering through this cluster are always available. So the core cluster resources are like the quorum, the IP address and network name, and here's the 4-point process to making that move happen. Because like I said, it's never a set and forget. It's definitely something that you'll have to come back to upgrade, to manage, to remove, you know, to do your usual management work. And you can do some of this in PowerShell. Advanced quorum settings is within the cluster manager. You'll have these choices to use the default quorum, select a quorum witness, or advanced. If you select the quorum witness, which is the second option, you'll specify how you want the quorum witness configured, which could be a disk, a file share, cloud, or not. You'll be able to choose which nodes have a quorum vote in the cluster. By default, all of them do. Now, if you remove all voting from all the nodes, you need to have a disk witness, because the cluster needs to know who is down and how many to bring up depending on how you configured it. So it needs to have a place to see who's up and who's down. You can set it up dynamically, so it chooses on its own. So you don't have to manage it, and it can handle that by itself. You can also use Cloud Witness. so that your cluster essentially is connected not just on-prem, but also up on the cloud. Which could be useful if, say, your on-prem loses power and you have critical services running. By having this cloud witness, the cloud witness could take over and nobody would feel the difference. Your users would be fine, even if your on-prem system is out. So it's within Azure that you can set that up. There you create your storage account. You'll need some access keys that you'll add into your on-prem system. That way they're both connected together. And then you go through the configure cluster quorum wizard. Once it's all set up, you'll see it online. So if anything happens locally, our cloud witness can take over. Your cluster aware roles, are all of these that will be able to happen on-prem and on cloud. Your main three categories for generic applications could be these three for a failover cluster. With any generic, so like non-Microsoft specific stuff, it'll periodically query to see is that application or service running. And it does have fewer ways to find out if it's an operational state, but you can still use non-Microsoft services and apps. The file server role can be used also for high availability. So this can handle, a lot of file read and writes throughout a cluster. And if something goes wrong with one node, the rest can handle. So you can either have it as a scale out or general use. Once the file server is configured, then you have a couple more settings like continuously available, so that other nodes would have essentially grab a copy and clients wouldn't be able to tell the difference in case a server goes down. Again, having the two nodes and needing to evict one, you'll need to make sure that your roles are transferred. Doing an in-place upgrade can happen if you have server 12 and upgrade to 16, but you'll need to bring it down and then back up, since it can't really happen live. You can do a rolling upgrade, but that's available for the scale out file system or Hyper-V configurations, not so much for the others. You can also do an Active Directory detached cluster without needing AD for network name management. It'll still use DNS, but it won't depend on Active Directory. You can also create workgroup and multi-domain clusters, as long as we have things like DNS set up properly and have the right accounts everywhere, and you'll be able to do that. You'll be able to manage multi-domains and workgroups through a cluster. Your storage space for a cluster is kind of similar to the earlier. You can create it through the wizard or in the Failover Cluster Manager. You can also do cluster-to-cluster replication, just like server-to-server replication. So if you have multiple databases, or sorry, multiple data centers, they can copy each other to stay up to date, to handle availability, to do all that kind of stuff. It is possible to use the Windows Server Backup feature on a node. Just kind of interesting, but yeah, you can do it on that. To restore, it can be the authoritative restore or the non-authoritative. Like for authoritative, it's rolling back a configuration to an earlier point. The non-authoritative, taking basically the configuration and replicating it. There are also stretch clusters. If there's an even number of cluster nodes with a Cloud Witness quorum configuration, can be done for multi-site. And you can also replicate data between these stretch clusters. So again, you'll need a heartbeat setting. And you have some different settings for heartbeat that can be configured between these two clusters in order to talk to one another. You can also set site-aware failover clusters. So you have physical locations, and those become cluster nodes. So if a site goes down, the other sites will have copies of the information and will be able to fail over to a node at a different site. Similar to like VMware, where you can have a configuration and VMs move from one site to another. So in case the site goes down, life continues. You can do a very similar thing with Windows clusters. And speaking of virtualization, this section will do high availability within Hyper-V. So again, it is possible, just as with VMware, to have virtual machines in a failover state with each node having its own volume and being able to have your VMs on no matter what. When you create a VM, you can do it within the Failover Cluster Manager. That way it's already set up to be high availability. It is possible to move a VM that already exists into the shared storage so that it is so it becomes high available. And then you'll configure the role and actions. In order to shut down a node, or at least the best way to shut down a Hyper-V cluster node is by either pausing and selecting the drain role. The drain on shutdown will drain any roles automatically and live migrate virtual machines to another cluster before that system goes down. Useful in order to keep VMs up without the VM knowing that there's something happening. You can implement node fairness, helping to optimize the usage of failover clusters or cluster node members. The VM movement, of course, happens with live migration. That way there is no downtime. The node loads are always figured out by the CPU memory utilization. So if a host is too busy, it probably won't receive the VM. Another one who's not so busy will receive the VM in order to keep it up. So you can set it to automatically balance within your cluster and how aggressive you want it to work. The resiliency can be set so that VMs are unmonitored, isolated, quarantined as needed. Any high available VM will lose access to storage when placed in a pause critical state. You can set up virtual machine monitoring on highly available VMs. Obviously, this is more of a Windows thing, so it should be a Windows host in the same domain as the Hyper-V host. And the user running the failover cluster manager should be a member of the local admins. It's one of those benefits if it's a Windows box. Then you'll set up a firewall rule in order to allow this monitoring to occur. And there it is. And there it is as well, on both within the VM itself and on the host. You can do guest clustering using 2 or more VMs with a guest OS and configuring it that way. This can help with monitoring clustered resources in the guest OS, Hyper-V optimization, and host failure protection, because talking with physical equipment, it's gonna fail at some point. So your VMs could use shared virtual hard disks or your VHDX files instead of a SAN in order to provide easier management between these VMs. There are some requirements in order to enable this, but it's totally possible for 2 VMs to be failovers of each other. So there's the where you would create the shared drive and select the VHD set. If we need to move a VM from one host to another, we have these options: the Hyper-V Replica, the live migration, the quick migration, storage, and VM import. The Hyper-V Replica is one of those automatics. If our site is down, then it'll, our hot backup site will take over. Systems have to be selected to be the replica server, so it's not done automatically. But you can authorize a machine to be the replication server. Then you can set the replication in a VM itself. You can set up a replica broker used to configure the replica between the cluster nodes. So it'll handle the management of the nodes. The extended replication is a backup of a backup, a replica of a replica. So if we have multiple data centers, we can enable this so that one copy goes to another and to a second and a third site, especially when we're talking big data centers. Another option for moving our VMs will be a live migration. They do need to have some settings, some similar configurations of each other. This is enabled by default on the clustered Hyper-V server. And you can do any of these. The cluster live migration with the shares, shared nothing live, or cross version live migration. If you're going to do a cluster live migration, you have a few more items to include. And to select it's within the VM in order to enable this. If you're doing it with SMB shares, it is also possible. Permissions have to be set up, of course, to grant access. And you'll need to set this up on the source Hyper-V server. The shared nothing live migration can be done with two Hyper-V servers that don't have common storage. So you do have that option in case you don't have a shared storage for the two. It is still possible to make the transfer. And the cross can be done between, like 2012, 16, or 19, allowing you to perform the Hyper-V update without affecting the downtime of a VM. Quick only happens within a failover cluster. This will copy the VM data to the destination node, saving the state. This is definitely something that would be done more locally. It is also possible to do storage migration, where you need to move a VM storage from one volume to another without moving the VM to another Hyper-V server. So the Hyper-V server is the same, it's the storage that we're moving. This can be done while it's running, while the VMs are running, or when they're shut down. So an idea of current storage is filling up, so we need to transfer, or we're upgrading the type of storage from a spinning disk to a solid state. And of course, the tried and true exporting and importing of VMs is another way of copying. There is the network health protection that'll move a VM from one cluster node to another if it detects that a network has been disconnected. It's a feature that you'll need to enable or disable if needed, if you're going to manage it or take it offline. The storage space is direct. Can do storage pools among all the nodes. And then any new nodes that are added, their storage can be added into this pool. So you'll need at least 2 to 16 servers. A high speed connectivity would be recommended. at least 4 locally attached drives. You can either do the hyper-converged or the disaggregated method to deploy. As always, if you don't have the hardware to handle it, it won't work. You can enable this through PowerShell and create the pools. Then you'll take your new volumes and add them into the pool. To do hyper-converged, the storage and Hyper-V role have to be in the same cluster. Your disadvantage is when you scale, it's an all or nothing. But the advantage is there of one cluster to manage and less network traffic. So here's your hyper-converged, where we have our storage pool from these boxes together to create those virtual disks that our VMs use. In a disaggregated, you can do an S2D or a Hyper-V cluster. The Hyper-V cluster can be scaled independent of the storage cluster, so they're not tied together. The disaggregated will use the scale out FS and offer CSVs to the hosts. Awesome. This chapter was a little long and had a lot of info. Any questions? I don't see any anywhere. So as always, if you do come up with any questions, feel free to ask away in Discord. But like I said at the start of this, if you missed it, I know that this is the time when students start submitting more assignments because we're starting to get towards the end of the semester, believe it or not. And I am cognizant of it. So I will do my best to stay on top of all the assignments you start turning in, so you know your grade. But just know that I accept assignments all the way up until the due until date. And with that, I'll stop the live show.